So we've used the URL class loader, which is one of the classes that comes as part of the Java Virtual Machine, the JVM. We'll now take a look at writing our own class loader, something that doesn't rely on the URL class loader. So when we write our own class loader, there are several things we have to think about. Our class loader will not load all the classes that the application asks for. It will delegate to other class loaders. So by the system class loader here in quotes, I mean that we'll delegate to things like the application class loader, that will then delegate to the extensions class loader, that will then delegate up to the bootstrap class loader. When we delegate, the parent class loader, if it can't load the class, will throw an exception. It'll throw a class not found exception. And our class loader has to handle that exception. When we find a class not found exception, our class loader will then look in the database. So we need to configure the class loader with a connection string that points to the database we want to use. And then the class loader will use a particular structure of that database. We'll have a specific table, and that table will contain the actual bytes that make up the class. So we'll load in those bytes into memory. Once we load the bytes into memory, we then use the built-in class loader class's define class method. So we pass the define class a byte array, and that byte array contains the byte code of the class that we are trying to define. The example we create will use SQL Server. I'll provide scripts as part of the code to allow you to insert a class file into the database and to show you the actual command line that we need to run the Java application if you're using SQL Server. So the code we have here is similar to the code from the previous demonstration, except that now we have our own SQL Server class loader to which we pass a connection string, and that's going to load the class for me. And in this case, we're asking it for a class by name. So we're asking it for this com.pluralsight.quote class. And then once that class has been loaded, we create a new instance and cast that to be an iQuote, and then print out getQuote again. This class is loaded into SQL Server, and here's the table. We have a table called classes, inside a database called class loading, and this is the actual class file in the table. And notice it starts with 0xcafebabe, which is the signature that's the start of all Java class files. And the name we give it here is com.pluralsight.quote. In this demonstration, we'll write the SQL Server class loader. So the code is here. So we'll start with a base class, SQL Server class loader, that extends class loader. And this has a couple of constructors, one to which we can pass the parent class loader and the connection string, or one to which we simply pass the connection string. This then calls classloader.getSystemClassLoader to set the parent class loader. And it's this class loader that we'll delegate to. So we'll need a method to get the binary data from the database. And that method is a JDBC method. I won't go into details here, but we create a connection. We create a prepared statement to get the class data from the classes table with a specific class name, and we load that data as a blob, so as a binary large object, and then take that blob, extract the bytes from it, and save this into a byte array, and return that byte array to the caller. So to make this our class loader, we need to override the findClass method. So findClass takes the name of the class and returns a class object, so it returns something of type class. This method will call loadClass from database, and if it can find the class from there, then return that class. Remember that the first thing this method does is delegate to its parent. So we'll call our parent's loadClass method. If that fails to load the class, then that will throw a class not found exception. And from here, we need to return the class that's been loaded. So if we get a class not found exception, it's now down to us to try and load the class. And we need to make two method calls. We'll call loadClass from database, passing in the name of the class. If that succeeds, that will return as a byte array, and then we can call define class on that byte array. We need to wrap these in a try catch, and if we catch a SQL exception, then throw a new class not found exception, passing in the SQL exception that caused the error in the first place. And with that code in place, we should now be able to load a class from the database. The code for running this app is slightly more complex than normal. We have to specify a Java library path here. That points at a DLL that SQL Server JDBC driver uses to provide authentication. and we have to specify as part of our class path the path to the SQL Server JDBC driver. Apart from that, it's the same. We have the interfaces.jar, we have our client library that contains the quote interface, and then we'll run com.manteaser.main. So from a command prompt, if I simply do run the application, which will load the quote class from the database, cast it to be of type iQuote, call getMessage, and print the message on the screen. To hopefully prove that this is doing the correct thing, let's change the name of the class here from com.pluralsight.quote to com.pluralsight.quota. Again, build the application. So if we run the code again, we'll now end up with a class not found exception here. And this is coming from the load class from database call. So load class from database can't find the class. That throws the class not found exception, and that's bubbled back up into our code.